Hello everyone, welcome to the next lecture on the real analysis. Today I will explain you how you can solve the uniform convergence problems. Myself Dr. Harish Garg, you can follow my YouTube channel where you can find the playlist of real analysis, and you can see that the previously I have defined the pointwise convergence, its example, Cauchy criteria, uniform convergence of the sequences and many more. Apart from them, you can see the complete playlist covering the infinite series, sequences, convergent, monotonic, and all available in this single playlist. You can subscribe my YouTube channel so that when I uploaded my next video, you will get the notification. So what we have discussed in our last lecture related to the uniform convergence, if you have the sequence Fn, then this sequence Fn will converge uniformly on the domain A if for a given epsilon greater than 0, there exists a positive integer m such that this equation will be satisfied. You can note down this definition in your copy so that you can remember it, and then you can easily understand what is the how you can solve the examples of the uniform convergence. Now, how you can check about the uniform convergent? Whenever the question asks you proof or disprove the uniform convergent, then you need to check about the pointwise convergent firstly, and then you have to check about the uniform convergent. If your limit of the fnx will exist, then it is a pointwise convergent. Fine. Remember student, if the limit does not exist, fine, if the limit does not exist, then it is not pointwise convergent. If it is not pointwise convergent, implies it is not uniform convergent. But make sure, if the limit exists, then it implies it is a pointwise convergent. Then it doesn't implies that it is uniform convergent. It may or may not be uniform convergent. Fine. It may or may not be uniform convergent. Then the question arises is how we can check about the uniform convergent. The first one is, there are the two methods. The first one, we can check about the definition, that is fnx minus fx less than epsilon, and second method is called as the mn test. Fine. However, in this lecture I will explain you how we can solve the problem based on the definition of the uniform convergence. So look at that. I have explained you the 8 to 9 example in this lecture so that you can understand this lecture easily. You can watch this lecture till the end so that you can learn the concept in a very simple manner. And don't forget to like and comment on this video. Show that the sequence converges uniformly on the interval a comma b such that a is my positive. Fine. That is an open interval of a to any b, but only pointwise convergent when a also 0. So now since they are talking about the uniform convergent, fine. So your target is to find these 2 points, pointwise and uniform. So once you are talking about the pointwise, your target is to find the limit of fnx. Now clearly say my domain is close interval 0 comma b. So that means you have the 3 cases. If x is equal to 0, or you can say that 2 cases, x is 0 or x is non-zero. Fine. Or you can see that instead of the x non-zero, because x b is my positive, then only the interval, I can say x is my greater than 0. Fine. So I can take the 2 case when x is 0 and when x is non-zero. So case 1, what will happen if x is equal to 0? What is the value of the fnx? What is the value of the fnx? Is my 0. So therefore limit is also my 0. On the other hand, when x is my greater than 0, then your fnx will be my nx over nx plus 1. It is clearly infinity by infinity form. Then I can apply the L'Hopital rule. What is the L'Hopital rule is, you can differentiate this with respect to n. It is x over x, because x is my non-zero, so the limit is my 1. So therefore my function is my 0 and 1, which is my existence. Fine. Therefore fnx converges to my fx pointwise on the interval 0 comma b. Now second part, we have to check about the uniform convergent. That means your target is to verify this case. as I have defined the two different cases for the pointwise, so similarly I can define the two cases for the uniform convergent. And your target is to find fnx minus fx. What is the value of the fnx when x is equal to 0? 0. What is the value of the fx when x is equal to 0? 0. So 0 minus 0 is 0. Look at this case. The value of the fx when x is non-zero, it is nx plus 1 minus the value of the x is greater than 0, the value of the fx is my 1. So if you solve this calculation, it is minus 1 over nx plus 1. So since it's a modular sign, I can call it as a 1 over nx plus 1. Fine. Now I can substitute this value for the first case. 0 is less than epsilon. That's true because epsilon is always greater than 0. So I can find the second case. Can you find the value of the n from this case? So definitely you can find 1 over epsilon is nx plus 1. So therefore n is greater than of 1 over x, 1 over epsilon minus 1. Fine. Now always remember, listen carefully this student. Whenever you reach at this point, then you consider the two different cases. Case 1, case 2. Always. For each of the example. Case 1 is you can find the value of the x from this interval. Fine. Or instead of the interval, can you find the value of the x so that this limit will goes to the infinity? Can you find the value of the x so that this limit will goes to the infinity? Yes, you can find. If I simply choose x will goes to my 0. If x goes to the 0, then this limit will be my infinity. Fine. So therefore, we can say we can't choose the value of the small m such that this condition hold. So I can say x is 0. X is 0 is the point of non-uniform convergent. Is a point of non-uniform convergent. Or in other words, if you are in the competition examination like CSR net, GATE, NBHM, anyone, if somebody will ask you, does this interval, does this fx is uniform convergent on this case? Answer is no, because 0 belongs to this case. Fine. 0 belongs to this case. Therefore, fnx is not uniform convergent on this interval. However, if your interval is 3, 4, then clearly say 0 does not belong to the 3, 4. Then the function is uniform convergent. So this is my case 1. When x approaches 0, this becomes my infinity. Case 2. What is the case 2 is? You always look to find the maximum value of this one. Fine. So now my interval is a comma b. What is the maximum value of 1 over x? 1 over epsilon minus 1 whenever x lies between a comma b. So clearly say this term is my constant. Fine. So the maximum value of this, when it will be the maximum, when this term will be my minimum, because it is 1 over. So x will be minimum at the point of a. So therefore the maximum value of this will be 1 over a, 1 over epsilon minus 1. Fine. If they are asking you find the minimum value, when it will be the minimum, when x will be the maximum, that is my b. But since we always find the maximum value, so therefore we can choose the value of the m so that m is my greater than of this number and it is greater than of 1 over x, 1 over x minus 1. Why? Because this number is the maximum value of this quantity, and this result is true for all x greater than of, for all x lies between a comma b. Therefore fx is my uniform convergent for all those interval in which 0 does not belongs, and clearly say in this case 0 does not. So this is the first example. Look at that another 7 to 8 examples so that you can understand this concept easily. So we can say the function is not uniform convergent on the closed interval, but only pointwise convergent of the closed. Okay, look at this another one. Again, you can see it's a similar question, but the function is different. Again, your target is to find the pointwise and uniform firstly. So firstly, you can find the pointwise. Again, x is my greater than equal to 0. I can consider the two cases when x is 0 and x is my greater than 0. So what will happen if x is my 0? What is the value of the fnx? So if x is 0, the value of the fnx is my 1. So therefore, the limit of n approaches infinity is also my 1. When x is my greater than 0, what is the value of the fnx? The value of the fnx is e raised to power minus nx. And then what is the limit as n approaches infinity? Because x is my non-zero, so this limit will goes to the 0. So hence you have a two limits, 1 and 0 both are existence. Therefore the sequence is my pointwise convergent to this function f. For the uniform convergent, again you have the two different cases. So I will again consider the two cases for the uniform convergent. What is the value of the fnx when x approaches 0? 1. What is the value of the fx when x approaches 0? X is equal to 0 is my 1. Similarly, for this case, it's a e raised to power minus x minus 0. So this will be e raised to power minus nx. Fine. I can substitute both the values when 0. So 0 is less than epsilon, satisfied. And the second case is e raised to power minus nx is less than of epsilon. Can you find the value of the n? So yes, you can take the logarithm on the both side. So minus nx is log of epsilon. And can you find the value of the n? It is minus 1 over x because it's a negative. So the inequality will change. It is log of epsilon. Fine. I can adjust this negative sign. I can write this number is log of 1 over epsilon because log 1 over epsilon is minus log epsilon. Again, you have the two different cases. Case 1, can you find the value of the x so that this limit will goes to the infinity? Can you find the, yes, again, if x will belongs to the 0, then this limit will goes to the infinity. And the case second, you have to find the maximum value of this 1 over x log 1 over epsilon. So clearly say when x approaches 0, then this limit will goes to the infinity. So therefore, what you can say, we can't choose the value of the m so that this condition will be satisfied. Therefore, x is equal to 0 is the point of non-uniform convergent. Fine. Or in other words, you can say fnx does not converges to the f uniformly on any interval which contain 0. Fine. On any interval which contains 0, like minus 3, 7, fine, minus 4, 9, minus 1, 1, 0, 7, and so on. In all the cases, 0 belongs. So this function is not uniform convergent on any interval. Case second, you have to find the maximum value of 1 over x log 1 over epsilon for all x belongs to the a comma b. Again, this quantity is my constant, fine, and your target is to find the maximum value. So how you can find the maximum value? Because it's x in the denominator, so this value must be minimum. So what is the minimum value of the x? X is the minimum value a. So therefore, the maximum value of this quantity is 1 over a log 1 over epsilon. Therefore, we can choose m such that m is greater than of 1 over a log 1 over epsilon. Now since this number is my maximum value of 1 over x log 1 over epsilon and it is true for all x belongs to the a comma b. Therefore, the function is my uniform convergent on all those intervals which does not contains my g. So therefore, the function is not uniform convergent on the closed interval 0 comma b However, you can also say the function fn converges to the f uniformly for all those intervals in which 0 does not belong. Look at the third example. I hope you can like and comment on this video. Show that the sequence is not uniform convergent. Fine. How you can prove that not uniform convergent? If you prove that it is not piecewise continuous. Fine. This is the method 1. Fine. Second method is you can find the value of the n which is greater than of something and prove that this number will goes to the infinity. Fine. So now, how you can find the pointwise convergent? Again, you have to find the limit of the fx. Clearly say, now the domain is my complete R. But you can see that whenever x is my 0, this limit will be 0. This function is 0. Whenever x is my non-zero, this function is again my non-zero. So I can consider the two different cases. When x is 0, x is non-zero. When x is 0, f and x will be 0. So therefore, f of x is my 0. When x is non-zero, then your limit will be this. I can divide it numerator and denominator by n square. It will be x over n, 1 over n square plus x square. Now if you take the limit 0 and is infinity, 0 plus x square. Because x is my non-zero, so therefore this limit will be my 0. Fine. Second method, because you can see that this is my infinity by infinity form. So I can apply the L'Hopital rule also. So that's on your choice. So that will be x over 2n square x square. So 2nx. Fine. It's a 2nx square. Clearly say as n approaches infinity, this will be my 0. So what we can say, fx is 0 when x is non-zero and x is 0, both the cases is my pointwise convergent. Now for the uniform convergent, again you have the two cases. We have to find this value fnx minus fx, which we have obtained as a 0 for the first case. Similarly for the second case as, why we have written as a mod x? Because x is my complete real line. It can be positive, it can be negative. I can substitute this value of the fx minus, in this case we can find this expression. Then your target is to find the value of the n. So I can multiply both sides, epsilon n square x square. So clearly say this equation is my quadratic in n. Fine. So I can write this equation quadratic in this form. How you can find the solution of the quadratic? Minus b plus minus b square minus 4ac over 2a. This is my a. This minus of b is my b. And this is my c. So my solution is this one. Again you can see I can take an x square, that is mod of x common from the bracket. So it is 1 minus 4 epsilon square divided by 2x square epsilon. So 1 mod x is cancelled out. So this value becomes my mod x into mod x. So 1x will be cancelled out. Now again you have the two different cases. Case 1, can you find the value of the x so that this limit will go to the infinity? Can you find the value of x? Clearly say, if you take x is my 0, then this limit will be infinity. So what does it mean? We can't choose the value of the m such that this condition hold. Therefore, fnx does not converges to the f uniformly, on any interval which contains 0, and that's the given state. Show that the sequence is not uniform convergent in any interval containing 0, or you can say 0 is the point of non-uniform convergence. Hence the sequence is not uniformly convergent on any case. Now since in this case it is not asking you to prove about the case second, Otherwise, if you are interested to find the case second, you can find the maximum value of this, fine, and then you can solve. Okay, look at this another case. Show that the sequence converges uniformly. Now you have to prove that. Fine. So can you find the pointwise convergent quickly? For more detail about the pointwise convergent, I recommended you must watch about my examples of the pointwise convergent. Now, what is the value of the fnx? So again, you can see it is my closed interval. I have to take on the three cases. X is 0, x is 1, x lies between 0 and 1. So what will happen if x is 0? What is the value of the fnx? If x is 0, fnx is my 0. Again, the limit is my 0. Fine. What will happen if x is equal to 1? Your fnx will be 1 over n. So if you take the limit as n approaches infinity, so limit of 1 over n is my 0. When x is lies between 0 to 1, then your fnx will be x raised to power n over n. Now clearly say if you take the limit as n approaches infinity, since x lies between 0 and 1, the limit of the xn will goes to the 0 over n. So it will be 0. So now clearly say for each cases it is my 0. So I can say this is my 0 for all x belongs to the 0 comma 1. Fine. Therefore, fnx converges to the f point. For the uniform convergence, now since either you can consider two cases or three cases, but it is true for all x, so I can consider only one case because the limits is my same. Now clearly say x is my always positive, so x raised to power n is always positive divided by n. I can substitute this value in this given equations, and can you find the value of the n? Yes, you can find the value of n. N is my greater than of x raised to power n over epsilon. Fine. Now, can you find the value of the x? Can you find the value of the x so that this limit will goes to the infinity? So the only value of the x which is my infinity, but you can see that x is my all lies between 0 comma 1. So therefore, what you can say, this limit does not goes to the infinity for all x belongs to the 0 comma 1. Hence, you can find the max. Therefore, first case is cancel out. Then you can find the maximum value of. So how you can find the maximum value of x raised to power n over epsilon? Clearly say this epsilon is my constant. Fine. So the maximum value of this will be when x will be maximum. So when x will be maximum at my 1. So the maximum value is my 1 raised to power n over epsilon. That means 1 over epsilon. Therefore, we can choose the value of the m such that m is my greater than. It is greater than of x raised to power n over. So therefore, the sequence is my uniform convergent and it convergent to my same limit 0. Look at this another example. Again, they are talking about the convergent, pointwise and uniform. Target is always remain the same, pointwise and uniform. Can you find the limit of this? Clearly say it is my limit. Fine. So we can consider two cases. When x is 0, fine, because the domain is my 0 comma b, and when x is greater than 0. So when x is 0, what will happen if x tan inverse 0 is my 0? When x is my greater than 0, then limit x is my non-zero, then tan inverse of infinity, that is my pi over 2. So you can see both the limits existence, therefore function fn converges to the f pointwise. Fine. Now for the uniform convergent, again you have the two cases. So I can take on the two cases when x is 0 greater than 0. What is the value of the fnx when x is 0? 0. Fx when x is 0, 0. So that will be my 0. Similarly, I can substitute this value as tan inverse nx. What is the value of the tan inverse nx? Minus pi by 2. We all know tan inverse a plus cot inverse a, which is equal to pi over 2. So that what is the tan inverse n? It will be my minus cot inverse nx. Fine. So because of this modular sign, I can take on this number is my positive cot inverse nx. Now clearly say 0 is less than epsilon satisfied. So we can take it as the second case. Can you find the value of the n? Because cot, what is a cot? Cot is a decreasing, cot inverse is a decreasing function. Fine. So I can take an cot on the both sides. So this inequality will be reversed. Now again you have the two cases. Case 1, can you find the value of the x so that this becomes my infinity? Yes, when x approaches 0. So the case 1 is when x approaches 0, then this limit will be infinity. Therefore, we can't choose the value of the m. Hence, f and x does not converge to the f uniformly on any interval which contains 0. Fine. So that means only pointwise convergent on the interval 0. And you can see in this case 0 is not blocked. Now this is the case 1. Case 2, your target is to find the maximum value of cot epsilon divided by x. So how you can find the maximum value? Again you can see the numerator is epsilon, which is my constant. So this value will be maximum when, because it's a reciprocal, it will be minimum. What is the minimum value? A is my minimum value. So what is the maximum value of the cot? It is 1 over a cot epsilon. Fine. So therefore we can choose the value of the m so that this condition, this is the maximum value of my cot epsilon over x for all x lies between a comma b, provided a is my non-zero. Therefore the sequence is convergent uniformly for all those intervals in which 0 does not belong. Look at this another example. Show that the sequence convergent uniformly on the 0 comma k where k is strictly less than 1. Again the target is same, pointwise and the uniform. So can you find this limit? Now the interval is my 0 comma 1. So we have the three cases, x0, x1, x lies between 0 and 1. So what will happen if x is 0? What is my fnx? Fnx is my 0. So the limit is also 0. When x is equal to 1, what is my fnx? Fnx is my 1. So limit is my 1. When x lies between 0 and 1, so this limit will be my 0. So this is my 0. Fine. Or you can also write these quantities combined, because 0 and 1. 1 only when x is equal to 1, and 0 when 0 is less than equal to x is strictly less than 1. Either you can write like this manner or by the three different cases. Fine. So we can see the function is my pointwise convergent. Now for the uniform convergent, now we can consider this case. Again, we have the two cases when x is 1 and x lies between 0 and 1. Fine. When x is equal to 1, fnx is my 1, 1 minus 1, 0. So we can consider only this case. Fine. So what is the value of this? It is x raised to power n minus 0. That is x raised to power n. So I can substitute this value. Can you find the value of the x? So I can take on the logarithm on the both side. N log x is less than of the log epsilon. So can you find the value of the n? Now clearly say x is lies between 0 comma 1. So what is the value of the log of x? It is my less than 0. Fine. This number is my negative. So if you taken this negative quantity on the right hand side, it must be greater than sign. So n must be greater than of, I can replace by the 1 over epsilon. fine, so that negative will be removed. Again, you have the two different cases, fine. So can you case 1, the numerator value is by this case, denominator is, can you find the value of the x so that it becomes my infinity? Can you find the x? Yes, definitely x. If x approaches to the 1, then this will be my infinity. So therefore, we can't choose the value of the m. Therefore, what is meaning of that? Fx does not converges to the f uniformly on any interval which containing 1. That means if you are in the competition exam, which of the following interval will be my uniform convergent? Now since 1 belongs to this, it is not uniform convergent. -3, 0. 1 does not belong to this interval, then in that case it's my uniform convergent. Now the second case, your target is to find the maximum value of this quantity log 1 over x. How you can find the maximum value of this number? Again, this number is my constant. Look at this quantity. Maximum value only when this value will be minimum. Fine. Clearly, it is a minimum. But you can again see that it's a log 1 over epsilon. Fine. So we can find the minimum value as when, sorry, but it's a minimum, but again because of the 1 over x, so this number will be my maximum. So what is the maximum value of this? Is my k. So hence I can say the maximum value is my log 1 over epsilon log 1 over k. Therefore and definitely k is my non 1 because k is equal to 1 is the case for the case 1. This number is, because this is the maximum value of this quantity, I can write this number is, hence fnx converges to the f uniformly on all those interval which does not contain the 1. Okay, we will see the next lecture on the MN test of the uniform convergent. But again, I suggested you must watch about my these previous lectures on the point-wise uniform, Cauchy, and many more other lecture in this playlist so that you can understand the concept easily. I hope you can like, share, and comment on this video. Happy learning always, and don't forget to subscribe my YouTube channel. Thank you for the support. Best wishes all.